All right. How are you? I hope that you're doing awesome. And I'm choosing to begin today by going back to last week where we left off. And I want you to just take a moment to think about if you're doing what it takes to succeed in class. Let's go through the bullet points that we use at the end of every week. Did you do all the homework when it was due? Remember, it's kind of like having extra credit. And so many students at the end of the market period, well, let me backtrack a little bit. I don't think that I've taught any students who have ever been in danger of failing because of a lack of intellect and understanding how to get the questions right. I have had students who've missed a lot of homework during the semester and missed a couple of quizzes or a test during the semester, and then they're about to fail and they look up and they say, "Oh my God, what can I do for extra credit?" And let's be clear, as I've been from the beginning, there is no extra credit. The closest thing that comes to extra credit in this class is for you to do all of your homeworks on time. Then it's kind of like having 10 points added to your average. It's not exactly the same thing, but it's close enough to think of it that way. Make sure you're doing your homework. It's such a benefit if you have a set time every week when you do your homework, or if you always make sure to do it right away. I'm a do it right away kind of guy. You know, when I was in college, I went to school for 8 semesters and I paid my own way through school. I got no help from anyone. I got $700 from my parents in 4 years. And the other thing that I got was I was on the dean's list for 6 out of 8 semesters. I was not on it for all 8 semesters. And the first semester that I ever struggled with my grades in my life was the first semester of my sophomore year. And I made a really big mistake. I moved off campus with a bunch of seniors. And I'm not a party person. I've never been drunk in my life. I've never smoked a cigarette. I have never done a drug. Never any of that. That kind of scene does not appeal to me, and I can't stand cigarettes. So what I do love is sports. and I don't mind hanging out with some girls. So I got caught up in going to parties and dancing. And at this point in time, the band the B-52s was very popular. The Ramones were very popular. And we would go to parties and we would dance and have some fun and enjoy ourselves. And I kind of stopped paying attention to my schoolwork. And then I was the captain of a club hockey team. And I took that a lot more seriously than my grades. And I did really poor that semester. So at one particular point in time, I took a test. I can make a lot of excuses, but the bottom line is I didn't prepare, and performance is a function of preparation. And the test was out of 100, and I got a 7 on the test. I did terrible. I never got a 7 on anything in my life. Maybe 7 out of 10, but never 7 out of 100. So I went, and then I really, really buckled down for the final exam, and I wound up getting a 98 on the final exam. And I'm leaving a lot of the story out here, but I always like to ask my students, who am I? Am I the student who got the 7, or am I the student who got the 98? And the truth is that I'm both. If I don't do my work, if I pay attention to all the things that are fun and enjoyable, like dancing and going fishing and playing hockey, then you know what? I'm very capable of getting a 7 out of 100 on a test. And if I prepare and I focus and I do my work, I'm quite capable of getting a 98 on a test. And I think you guys are just like me. So how you go about your business, the second point, is really critical. Are you keeping your eye on the ball? Are you doing a really good job getting your work done on or before when it's due? Things like your homework. Things like saying to yourself, look, I'm not getting any extra credit in this class. So if it's really important to me to get A's and maybe I'm going to get an 88 or an 89, well, maybe if I do all those homeworks, that'll bump it up to a 90 so I can get an A. That's the way I hope that you're looking at things. I don't want you to feel too much pressure, because Lord knows when the work is done, Go play hockey. Go, if you're into equestrian stuff, go ride a horse. Go hang out with your friends. Enjoy yourself, but take care of business first, and then you can enjoy yourself with both a clear conscience and no ramifications to follow. Pay a lot of attention to due dates. That test I got a 7 on, I didn't realize there was a test until the day before, and it was on about a month and a half's worth of work. So I couldn't do a month and a half's worth of work in a day. Work together on projects. Take pride in your work. They did a study at Stanford University, and I hope we're beyond the point of thinking what I'm about to say is racist, because it is simply not. But they studied why Oriental students at Stanford University did better in mathematics and STEM-related projects or courses than non-Asian students. And they found that the Asian students and the non-Asian students spent about the same amount of time each week doing work. The difference was that for Asian students, an adult in the Asian community who worked in a field that involved the STEM subject matter, so let's say mathematics, and there was an Asian man who was an engineer who had done this for a long time, the Asian students would get together, and because the bonds in their community were so close, they would have an engineer or two every week come in and study with the students. The students never worked alone. They always had guidance, and they always worked with their classmates on projects. So if it's possible for you to collaborate, to find out who might be in a class and to work together on it, that's a really good way to do things. And of course, take pride in your work. Everything that you do has your name attached to it. I do a lot of writing for magazines, and sometimes I write to my publisher and I say, listen, if you want it this minute, I'll give it to you, but it's not as good as I want it to be. I'm looking for this out of it. In fact, I just got an email back today, and I said, look, I can give you this now, but I'd really like to include this other thing. And he wrote back and he said, Bob, not a rush. Take your time. Don't even worry about it. It's a photo I want to get. He says, get me the photo. Let's do that. So I take a lot of pride in my work because my name goes on that article. And I want people to equate my name with quality work, top quality work. And the last thing is, you should be thinking about this every day, man. You got a dream for your future. And you got to think about that. You got to work for it. Early in the year, I showed you a video called Be Phenomenal. And we really want you to be phenomenal and to realize your dream. And what it takes is just effort, priorities, going about your business the right way, really focusing on your future. And this does not mean you cannot have fun. Have a ton of fun. Just do it in a way that reflects the fact that your schoolwork is your priority. And I'll go one step further with this. And these are some strong words, but I think it's the truth, and I hope that you understand it. Many of you, I think, are getting help to pay your student bill. I know I paid 2/3 of my son's college bills. And for that 2/3, I felt he owed me something. I felt that he owed me his best, because that's my money that's paying that bill. So if you're getting help, it's not a free ride. There's a sense of, hey, my parents or my grandparents or whoever's helping me out here, I can't let them down. I know there was a point in college where I wanted to quit. I wanted to walk away. Enough was enough. I was engaged at the time, and my fiance was 3-4 hours away. I wasn't spending time with her, and I missed my family and stuff. And I was ready to walk away, but my grandparents always said to me that I was the first person in the family to ever go to college, and that I had to get the piece of paper. That was my grandfather's way of saying I had to get my diploma. And everything in my entire life that I ever needed, my grandfather was there for. Everything. He didn't pay the college bill, but he took care of a lot of things for me. And I could not let him down. I just couldn't do it. Thank God I couldn't do it. And thank God I made that a priority, because now my life has worked out really, really, really well. In fact, I couldn't have asked for it to be any better. So I did realize my dream, and it's all about how you go about your business. Okay, so with that in mind, let's go to Math 1200, Week 8, Lesson number 2. We are past the halfway point, starting to round our way in. And we have covered some juicy material this week. We'll do some new material next week too. We did new material last week. And then we're going to take a week and do some review. Okay. Now, week 8, lesson number 2. Let's get started. We're going over homework answers. We're going to do a brand new do it. We're going to review recent work. That's kind of the strategy every week. And I really like to come back and spiral stuff. Bring it around, bring it around, bring it around. Give you multiple opportunities to see content so that you get continually better at it. And then today's big topic is we started it the other day, and I really want to work a couple of problems with this. We got 2 or 3 of them in store. Solving quadratic linear systems. And then throughout the lesson, we're going to have some word problems sprinkled in. Okay, word problems, in case you haven't noticed it, it's a big emphasis in this class. Remember our strategy. Underline the things that are important. Make sure that we use all of those important things in setting up the problem. All right, here's the homework answers part 1. Always with the homework, if for any reason you cannot get these questions right, you reach out to someone in the class, you reach out to me, and we'll go over them. If you ever do want office hours, it's extremely important that you reach out to me first. We set a time, and you tell me what the topic you want to cover is. Okay, so now I'm going to move to the next sheet. If you haven't checked all your answers yet, make sure you do stop and start. Okay. Let's go here. The product of the ages of Callie and Katie is 130 less than the product of their ages in 5 years. And boy, oh boy, I'm thinking I didn't do this one. I did not do this one. So I don't want to mess up this video. We're going to save this for our next lesson. I will duplicate the slide and put it in there. For now, I'm actually going to skip over this. Sorry. Praxis power. Performance is a function of preparation. True for me. Like I said before, 798. True for you. Okay, old praxis questions. Give it a shot. Boy, isn't it good we took a little time to review fraction questions as we went along. Okay, now let's see what happens if he gets paid 2/5 of a half or 1/3 of 3/4, and which one is a better arrangement for him to take advantage of. What's important to understand here is in mathematics, of means multiply. So 2/5 of 1/2 means 2 times a half. You can simply cancel out the 2's, right? We talked about how to do that, and you get 1/5. Then 1/3 of 3/4, I could cancel out the 3's, and I get 1/4. Of course, I could have multiplied it. 1 times 3 is 3, 3 times 4 is 12, and simplify it. Then 1/4 minus 1/5 is 1/20. So you make 1/20 or about 5% more doing the option that says 1/3 of 3/4. So that's what you should choose, part B. Okay, next one. All right, so what do we got going on here? So, I'm getting the wheel of death. All right, there are 60 minutes in an hour. So there's 120 minutes in 2 hours, right? 60 times 2 or 60 plus 60. But in every 10-minute block of time, right, 25 widgets are produced. So if I divide the 120 minutes by 10 minutes for each block, that gives me 12 blocks. And remember, each block of time, each set of 10 minutes is 25 widgets. 12 times 25 is 300. Now, these are all praxis type of questions, and so much of it is your ability to read and kind of just write stuff down. That's important. Underline it. We've talked about that a whole lot. I know sometimes I underline, sometimes I don't, but you should underline always. And then work your way, grind out the problem. Okay. No choices for this, just factor 3x squared minus 4x plus 1. Go ahead. Okay, so I noticed that there's a lead coefficient of 3, no greatest common factor, so I multiply that 3 at the end. I get x squared minus 4x plus 3. That factors to x minus 3x minus 1. But I have to remember to divide back in that 3, that leading coefficient that I multiplied by, and that gives me x minus 1, x minus 1/3, but that's not really a factor. So we adjust that to 3x minus 1. And that's our correct factorization. So all of these type of questions were on the praxis test, and I think that you're fully capable of getting all of them right. All right, here's a question to start up. Do some stop and start on it. Another minute or so. Okay, so what I have here is I have a rectangular patio that measures 6 by 8, and I'm going to increase its area or increase its size to an area that measures 150 square meters. If both the width and the length are to be increased by the same amount, what's the number of meters? To the nearest tenth. Now, this nearest tenth, boy, that's a cue that often means to use the quadratic formula. Doesn't necessarily, but it usually does. Or it could also mean to use completing the square, okay? So here's the border around it, which is x. We don't know what it is. What I do know is the whole length becomes 2x's plus 8, and the whole width is 2x plus 6. We've done a lot of that. And then when I multiply those two, I have to get the increased area, which is 150. I factor, or I should say I double distribute everything. Okay, just check that out. Make sure you can follow that work. I get all my x's together. What do you think the next step is? Okay, now it has a 4 in front. They don't all share a 4 in common, but they do share a 2. So I will divide out the 2. All right. That gives me 2x squared plus 14x minus 51. And unfortunately, now there's no common factor anymore, so I'm going to have to go to multiplying the lead coefficient by the last term. Okay, because of that nearest tenth. Oh, actually, the nearest tenth said to me, let's go with the quadratic formula. So here it is. Let's see, I'm just going to pause for a minute and let you follow and catch up to that point. Okay, so when you crank the numbers out, I get x is equal to 10.6 over 4 or negative 38.6 over 4. The big difference in this is the first one we've done that says to the nearest tenth. So I actually go in my calculator and I do square root 604 and it'll tell you 38.6. Now, the problem with this is you cannot have a negative length, so that rejects the last answer. And then I just do 10.6 divided by 4 and I get 2.6. So the dimensions are increased by 2.6 on each side. The length is increased by 5.2, right? Two 2.6s, and the width by 5.2. 2.6s. Okay, reduce each fraction. Go ahead. Okay, first one. Remember, 25 over 20, they share a 5 in common. And then I can cancel out the 5s because 5 over 5 equals 1. And 1 times 5/4 just leaves me with 5/4. I'm going to pause in case you didn't follow that logic. You can do it now on the 10/14. Okay. 10/14, they share a 2 in common, 10 and 14. So I cancel out the 2's, right? Because 2 over 2 is 1. 1 times 5/7 is just 5/7. Now, it's even easier when it's letters because you can do it right away, right? So here's everybody thinking, oh my God, algebra. Algebra is so hard. Algebra is in a lot of ways, at a lot of times, not always, but in a lot of ways, it's easier than arithmetic. So if you said, oh, I can reduce 25 over 20 or 10 over 14, well, you darn well better be able to reduce this guy. You can cancel the x's. Y to the 4th is y, 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 y. And there's a y on the bottom. I cancel 1 on the bottom with 1 on the top. There was 4. That leaves 3 left. So that's y to the 3rd power. Or, as you remember, you could just subtract exponents, and there's really a little 1 on that y on the denominator. Okay, now we'll combine a little bit of arithmetic with a little bit of algebra. Just in case you didn't do it before, I pause a sec. Okay, so 3/9 reduces to a 1/3, right? And, oh, I made a boo-boo here. I made this, see, I changed the, let's focus on this one here. Ready? 3/8 to the 3rd over 9/8 to the 5th, not the 2nd, okay? 3/9 reduces to 1/3, and 8 to the 3rd over 8 to the 5th. There's 2 leftover a's, but this time there are more a's in the denominator. So the 5 minus 3 does leave a squared, but it has to go in the denominator because that's where more of them were. There's the 3 and the 9 reducing and the a's. Okay, let's have you try this one. Go ahead. Okay. Now, length and width of a rectangle find the length and width whose width is 10 centimeters shorter. Here they are. So x times x minus 10 is 171. We have done ones like this before. I think today is the last day we do one like this, and I want to make sure you're good at it. X squared minus 10x distributing equals 171. Let's get it all on one side. Factor. X minus 19 times x plus 9 is 0. Maybe it's the guy on the left. X minus 19 is 0. Maybe it's the guy on the right. X plus 9 is 0. Adding 19 to both sides, subtracting 9, I get x is 19. X is negative 9. But can't have a negative length, so we get rid of that. 19 and 9, right? If x is 19, then the other side is 19 minus 10 or 9. 19 and 9 are the dimensions of the rectangle. And one of the things I really like about these questions is I can then do 19 times 9. Oh, look, I get 171. I know I did it right. All right, 3 questions to work on now. Let's do just the first one. We'll practice that one, and then you can do the next 2. But let's do a refresher on number 1. Go ahead. Okay, so when I remember, it's factor and cancel, factor and cancel. All that you do is you factor and cancel. So I factor the numerator, which is going to be, remember, put the 3 at the end, right? X squared minus x minus 12, factor that, bring the 3 back in. You get 3x minus 4 times x plus 1. And by the way, here's a little hint. If you ever get stuck on the factoring, generally, this is not 100% true, and you can't always do this, but generally speaking, these problems have cancels in them where expressions cancel out. If there's an x plus 1 on the bottom, and that's the only thing there, there's a really good chance there's an x plus 1 on the top. So if you're stuck for a factor, you can always try x plus 1 what would the other factor have to be? Kind of like reverse engineering. We talked about this, right? And then you can find the other factor. If you can't do it the way you normally factor. If you do it the normal way, then by all means. That's just a hint in case you get stuck. Cancel out the x plus 1s. My answer is 3x minus 4. So, without further ado, on numbers 2 and 3, factor and cancel. Factor and cancel. All that you do is factor and cancel. Go ahead. Okay. I assume that your stop and start is done. If not, continue stopping by all means. Factor and cancel, factor and cancel. All that you do is factor and cancel. The correct factoring for the first one is 2x minus 3 times x plus 1. By the way, can you see now why I spent so much time factoring? Because we knew that factoring would impact your ability to do work later down the line. And if you can't factor, you can't do any of this work. That's why factoring is so critical. If you're struggling because you can't factor, make sure you should have reached out for office hours before this, but at least let's do it now. The denominator is 2x plus 1 times x plus 1. Oh, look at that. I can cancel the x plus 1s. Remember, when we cancel, one of them has to be in the numerator, one in the denominator, because that means you have a form of 1. X plus 1 over x plus 1 is 1. And then 1 times 2x minus 3 over 2x plus 1 is 1. 1 times anything is itself, even if that anything is a really ugly looking expression like 2x minus 3 over 2x plus 1. One last thing, you cannot kill those two x's. Remember mathematical matrimony, they are bonded. As I learned in high school, thou shalt not commit die, canceling, to parts of a put together or takeaway. All right, number 3, factor and cancel, factor and cancel. All that we do is we factor and cancel. Factoring the numerator, there's the difference of two perfect squares, x minus 3x plus 3. The denominator, 3x plus 1 times x minus 3. Oh, look at those x minus 3s. I cancel. I'm left with x plus 3 over 3x plus 1. I cannot kill these 3s because they are bonded. Mathematical matrimony. Ooh, now we get a little addition and subtraction. Let's do these one at a time. This is a little more complicated than we usually do, so let's work on this. Try number 1. Remember, got to have a common denominator because you must add or subtract the same kind of things. This is the same exact concept as puppy dogs and kittens or dollars and euros, pesos, any of the above. Go ahead. So the first thing I have to do is factor my denominator so I see what do I have going on here. So the numerator stays 3x plus 5, but if I factor x squared minus 7x plus 12, I get x minus 4 times x minus 3. Now on the right-hand side, the right-hand fraction, I have a 3 and an x minus 3. Well, what does the denominator on the left need that the one on the right has? Doesn't need anything. I already had the x minus 3. But what does the one on the right need that the one on the left had? And that needed an x minus 4. So I multiply by 1 in the form of x minus 4 over x minus 4. Now, I then say, okay, I have my common category or common denominator, and I distribute the negative 3. This is a little tricky. Let's follow along here. Ready? When I distribute that negative, it becomes add. Negative 3 times negative 3 times x is, ooh, I made a mistake here. Let me correct it. And that would make this. Okay. Sorry about that mistake. Ready? Negative 3 times x is negative 3x. And negative 3 times negative 4 is plus 12. Once I distribute that negative, I'm now in addition mode. 3x plus negative 3x is 0. 5 plus 12 is 17. So I have 17 over x minus 4 times x minus 3. Notice how going over my work revealed the mistake to me, right? So you should always check your work the same way that I checked mine on these videos. I have always made sloppy and careless mistakes. I've been doing that my whole life. However, when I make these videos, there are times when a mistake will appear and I can go back and correct it. And someone once said to me, how come you don't like start again and polish up the video? And I'd rather not do that. I'd rather make a mistake in front of you and show you how I handle a mistake and how I catch a mistake, because ultimately you will make mistakes and you will need to catch mistakes. Okay, so number 2, same idea. Let's factor each of the denominators and let's look what we get here. So the original denominator here this is the fraction. You can see the space in between. It's y minus 6 times y plus 1. And the original fraction here, you can see the space in between. The denominator is y minus 5 times y plus 1. So what does this denominator on the right have that the one on the left needs? It needs a y minus 5. So I put it there. Y minus 5 over y minus 5 is 1. So I'm not changing the value when I multiply by it. The one on the right needs a y minus 6. So I multiply by, that's supposed to be y minus 6 over y minus 6. Okay, here's my denominator. And then I just do a little algebra. Y times y is y squared. Negative 5 times y is minus 5y. And negative 7 times x is, or in this case, y is negative 7y. Again, I made that mistake. Look at that. Okay. Negative 7 times y is, might as well correct this as a y right here, right? And negative 7y. And then negative 7 times negative 42 is plus 42. And that would give me y squared minus 12y plus 42. And I don't think there's anything, I don't think that's factorable. Let me think real quick. Can I factor that? 7 and 6 make 13, so no, I cannot factor it. Okay, so here we go. I distributed the negative, so I get negative 7y plus 42, right? And then I combine the numerators and I get y squared minus 12y plus 42 over what my common denominator is. Now, what I was doing at the end there was I was seeing in my head if I could factor y squared minus 12y plus 42. So I was looking for two numbers that multiply out to 42 and add up to negative 12. And the closest I could get was negative 13, right? 7 and 6. So there are two numbers there are not any two numbers that multiply out to 42 and add up to negative 12. So I don't need to reduce it anymore. Okay, systems of linear equations. I just want to remind you of what our strategy is. There are two techniques. One is called the elimination method. One is the substitution method. This is the same slide as the other day. If the same letters are on top of each other, x's, y's, equals, numbers, equal sign on top of each other, we go with that elimination method. If, on the other hand, they are not on top of each other and the y's are not aligned, and particularly if it says one variable equals, like y equals or x equals, a equals, b equals, that's an indication that we should always use the substitution technique. So let's get started. Let's try these two questions. You handle the first one. Let's see what you remember from the other day, and then I'll go over it with you. Go ahead. Okay, so now I need to eliminate one of these variables. It never matters which variable you eliminate. And in the slickest world, you would realize that if I just multiply the top one by negative 2, it's a quick elimination. If you knew how to do that, run with it, go with it, awesome. But what if you don't? Well, we're giving a more mechanical way of doing things. And very similar to when I get common denominators and I say, what's the one on the left have that the one on the right needs, and vice versa? Here, I can do the same thing with the y's. What does the y on the top need from the y on the bottom? It needs a 4. What does the y on the bottom need from the y on the top? It needs a 2, and we're going to negate it because I want opposite signs. So I distribute the 4. 12x plus 8y is 24. I distribute the negative 2. Negative 12x minus 8y is negative 32. This is really strange. I did everything exactly right. But when I add them up, I get 0x plus 0y is equal to 8. And what that means is there is no solution. Think of it this way. If I was to put these two lines on a graph, they would have the same slope. And if they have the same slope, they're never going to touch. And it's where they intersect or touch that you get your solution. So sometimes it's possible to not even have a solution. Okay? And it'll always look like that. 0x plus 0y equals some number. All right, let's try the one on the right. Give it a shot. Remember, you can always get rid of the x or the y. They both work. Okay, so I'm going to get rid of the x's, and I multiply the top by 2 and the bottom by 4. I already have opposite signs, so I'm not worried about including a negative. Distributing the 2, I get 8x plus 6y is 30. Distributing the 4, I get negative 8x plus 20y is negative 4. Then I add them up. 6y and 20y makes 26y. 30 and negative 4 make 26. Dividing, and I get y is 1. Here's where we often run into a problem. For the most part, as long as you've been doing algebra, once you get to the point where it says x equals a number or y equals a number, you're all done. But when a variable or a problem starts with two different variables like x and y, you have to find both of them. So you've only found x. Now we're going to go back and get y. And to do that, we can use either of the two original equations. Never use derived equations, which are equations you get after manipulated, because if you made a mistake between the original and the derived, it'll never show up. So go back all the way to the original equations. I'm going to use 4x plus 3y is 15. Substituting the 1 for the y, I get 4x plus 3 times 1, which is 4x plus 3 is 15. Subtracting the 3, I get 4x is 12. Dividing, and I get x is 3. So x is 3, y is 1. And if I were to graph these lines, which we don't do in this course, they would intersect at the point 3, comma 1. All right. Now we got a couple of substitution technique, guys. Let's try the first one. Go ahead. Okay. So in the case with the first problem, it says y equals, so I'm going to substitute for y. Remember, we talked about the vending machine and how you could trade $1 for 4 quarters, then the machine would work. So I'm going to rewrite the negative 3. Oh, the y, I noticed it says y equals, so that means I substitute for y. I rewrite the negative 3x. I rewrite the negative. I write the 3, but I don't write the y because the y is equal to a 5x minus 3, a negative 5x minus 3, sorry. So I put, instead of the y, I put negative 5x minus 3, grouping symbols because it's for the whole thing, equals 21. Now, you've done questions like this for weeks now. This is not difficult. Distributing the negative 3, and I get negative 3x plus 15x plus 9 is 21. That gives me 12x plus 9 is 21. Subtracting the 9, 12x is 12. Dividing by 12, x is 1. Y, it's so much easier to use the equation that says y equals, so I just substitute the 1 in for x. Y is negative 5 times 1 minus 3. Y is negative 8. You could have used the top equation. That works too, but it's just so easy to use the one that says y equals. Okay, let's see you try the next one. Go ahead. All right, so now, again, it says y equals, so I'm going to substitute for y. If it said x equals, I would substitute for x. So I rewrite the 5x, I rewrite the minus, I rewrite the 4. I don't rewrite the y. I trade the y in for what it's exactly has the same value or what it's equal to. That's negative 3x plus 2. And then equals 9. Distribute the negative 4. 5x plus 12x minus 8 is 9. 5x plus 12x is 17x minus 8 is 9. Adding the 8, and I get 17x is 17, dividing, and x is 1. Same answer as before. Let's go and get y, substituting into the y equation. Y equals negative 3x plus 2, substituting the 1. Negative 3 times 1 is negative 3, plus 2 is negative 1. So x is 1, y is negative 1. So we have now analyzed solving systems of equations using elimination, which can only be done with linear equations, which are equations where there are no exponents. It's just x and y, or a and b, or whatever. And we've done the substitution technique. Now, for substitution, all right, that can also be used if we don't have only linears. It's the way we solve the quadratic linear system. Now, the other day, we worked on a quadratic linear system at the end of class. Let's see how much you remember and give you a shot to try this yourself. Go ahead. Okay, so whether you are a student in this class learning mathematics because you needed to graduate, whether you are a student in this class learning mathematics because one day you're going to teach the mathematics, or if you are a mom or dad in this class learning this material and wanting to know this material so that you can help your children when they go to school themselves, whatever you are, it's really important that you remember something. And I'm drawing a blank on what it is you're supposed to remember. Oh, this is it. Ready? They've done studies about how the brain learns. And you know how they can take the brain and they can visually image it where it's lighting up wherever you think the brain is thinking about a certain thing, if it's thinking at all. So they did this where they put a bunch of students and they photographed or recorded their brains for electrical impulses when the students were learning something under different techniques. And in one technique, the teacher demonstrated everything for the students and led them through. And what they found is that the brain did not show much electrical activity. But if the students did the problem first and got it right, there still wasn't much electrical activity as the teacher went over it, which kind of makes sense because if they got it right, they probably knew how to do it. But if they got it wrong and the teacher went over the work, the brain would explode with electrical activity. Tons of stuff would be going on there in the brain. What that means for you as a parent or for you as a student, or if you become a teacher at some point in the future, is you need to let people do the work before, or at least early on in the learning process. You can show them once, but after that, they need to do the work. If you just keep telling them how to do it, it's not going to work. And a really simple example of that from real life was my dad and my grandfather. My dad would have me, he'd say like, I don't know, whatever, build something or fix something. Fix something is a better example. And I would inevitably screw it up pretty early on. And he'd go, oh, forget it. I'll do it. Just watch me is what he would always say. And I would never remember what he would show me. But my grandfather, he would turn around and he would yell and cuss at me. If you ever saw the movie Gran Torino with Clint Eastwood, that was my grandfather. I mean, they could have modeled the character on him. And he even gave me the same car. But my grandfather never let me stop until I fixed it. He would keep making me work. And once I learned how to fix it, then in the future, I could get it right and fix it myself. So if you say to yourself, how come Mr. Lindquist, how come Professor Lindquist says do it, and he really didn't show me much about how to do this last time? Well, A, I did show you how to do the whole thing last time. But B, I know it's been a while and you might not remember it, but that's okay because I'm looking for that brain to light up. I'm looking for it to get stimulated. And if you just gave it an honest effort, remember, it's all how you go about your business. If you just gave it a really honest effort and you didn't get this right, what I'm about to show you is going to light up your brain, and then you're going to remember how to do it, especially because we got another example coming right after this. So we have to use substitution. It's the only way to do this, all right? So the y is equal to the x squared plus 5x minus 2, and the y also equals the x plus 3. Think about it this way. If y is Johnny and the other stuff is Bobby and Jimmy, if Johnny weighs the same as Bobby and Johnny weighs the same as Jimmy, then don't Bobby and Jimmy have to weigh the same? Or if Johnny has the same amount of money in his wallet as Bobby, and Johnny has the same amount of money in his wallet as Jimmy, don't Bobby and Jimmy have to have the same amount of money? So therefore, x squared plus 5x minus 2 must equal x plus 3. The minute you write that, we're practically done, because you're really good at this, right? Get everything on one side, subtracting the x and the 3. X squared plus 4x minus 5 is 0. You know how to factor. AM technique here. Multiply out to -5, add up to 4. Or on your calculator if you struggle with the factoring. I get x minus 1 times x plus 5 is 0. Maybe it's the guy on the left. Maybe it's the guy on the right. Add the 1, subtract the 5. I get x is 1, x is -5. Now, danger moment here. Yes, x is 1. Yes, x is -5. But I also need to go back and get y for each of them. That was kind of new last time. So x is 1, x is -5. And also I should remind you that anytime we have a quadratic, like here, x squared, you can get two solutions. So I'm going to, it's so easy with the bottom equation, right? I'm just going to rewrite y equals x plus 3 and substitute in the 1. And substitute in the -5. And I get y is 4 and y is -2. So the first solution, the whole solution, is x is 1, y is 4, which means like the point 1, 4. And x is -5, y is -2, which is like the point -5, -2. Okay. You try this one beginning to end. Go ahead. Okay. So the y equals x squared minus 3x minus 2, and it also equals 2x minus 8. So therefore, using substitution, they equal each other. Get it all on one side. X squared minus 5x plus 6 is 0. Two numbers multiply out to positive 6, add up to -5. That's -2 and -3. Maybe it's the guy on the left. Maybe it's the guy on the right. Add 2 to both sides, add 3 to both sides. X is 2, x is 3. Great, I got the x's. I got to go back and get the y's. And it's so easy to use that bottom equation. Y equals 2x minus 8, because you don't have to square anything. Simple math. 2 times 2 is 4, minus 8 is -4, and 2 times 5 is 10, minus 8 is 2. Here I go. I said it's 2, and then for some reason, I wrote -8. Oh, Wheel of Death. Hopefully it sets up right back soon. I really hate this Wheel of Death. Okay. And there we go. 2, -4, and 5, 2, which means they would intersect at this 2, 4, 2, -4, and 5, 2. If you remember, the quadratic it's shaped like a parabola, which is kind of like a U, so it meets at 2 points. The happy recap. Ready? Anything over itself is 1, so you can cancel it out. Word problems. Always coming back to improving at these. I know they're not easy. Keep working them. Underline anything important and use it. Check it off as you go along. That will set you up. And finally, solving quadratic linear systems, you have to use substitution. In a linear system, you can use elimination or substitution. I hope you have an awesome time working through on this next couple of the homework of this particular section as we go through the rest of the week, and we see you continually improving in this by understanding the concepts in math rather than trying to just memorize everything. If you find yourself reverting to the old ways and memorizing, please don't do it. Understand the concepts. It makes life easy. And by the way, once you understand the concepts, very little studying to do. All right? Very little. That should excite you. Have an awesome day. Take care.